Hey you guys, how's it going? Welcome back to the Let's Write an ECS mini-series. And in the last episode we did the component manager, which if you haven't seen, I'll link somewhere up here. I had some great feedback on the last video, especially from the subreddit community Game Engine Devs, so shout out to those guys. And it got me thinking, and I reckon the last episode of this mini-series I'm going to do an episode on profiling, performance, optimization, to see whether we can squeeze any more performance out of this ECS. And I won't make any changes until we get to that video so that we can see where kind of improvements are and why they make the ECS better. But for now, that's not what this episode's about. This episode's about the systems manager, and let's get writing. All right, here we go. So let's go over what we did last time. So we had the component manager. We can register the components. We can add a component to a specific entity of a specific component ID, and then this is the component that we're adding. We can then get that component back out and we can print it. We can then update that component, and then just to prove that kind of we're updating the ECS, not some local, we get the component again, and then we print it. And if we run that, you can see here that entity 4 has 123, 123, and then it has 273893 1099. So today we are doing the system manager. So let's start with a lovely header file, and of course a header guard. Include ECS system manager. Systems or system manager? Systems manager. Systems manager. Let's do systems manager. And we're going to create systems manager. And then, very similar to what we did last time, we're just going to write out the responsibilities of the systems manager. So let's do the responsibilities. Responsibilities. Number 1, you want the systems manager, or you want to be able to register your system with the systems manager. So you basically want your system to be able to be informed when kind of entities with components that your system's interested in are created or kind of registered. You should be, let's change this to you should be able to register. You should be able to register, or you should be able to register, or you should be able to specify components that your system is interested in. And lastly, you should be able to get a reference to your system. So let's, very similar to what we did with the component manager, I'm going to change, no, this is going to be system manager, because it was called component manager, not system manager, and yeah. Let's change this, let's get rid of this, and then just to match, right, so we're going to do the same thing that we did with the component manager. If you remember, like registering components, we're effectively going to do exactly the same thing, but we're going to add a little difference to this. So let's make a new ID, and we're going to do the same thing, but for systems. System type. and then system ID. Perfect. And then what we can do is we can system ID, template, type name, system type, register system, and that's, oh, we need to include. That's perfect. So here we're going to register a system, and we're going to get the system ID back exactly the same way that we did with components. And what I'm going to do is I'm going to store systems in a vector of std unique pointers and of a system type. And what we need to do is we need to bring in include vector and include memory. And then also we're just going to declare this here. So effectively every system that you make must inherit from the base class system so that we can store them in this vector. Now, if we just do the same, let's do the same thing that we did with the components, and then we're going to think about what other things we might need to what other things we might need from a system to kind of register it. So here we can create a system ID, and we're kind of registering that. But what do we really, how do I describe this? Well, first of all, I suppose, let's get rid of this. First of all, we're going to have to instantiate the system type into the systems vector, right? So let's do this and place back make unique system type like this. So here what we're doing is we are placing back into the vector. So we're constructing in place this type as a well, a unique pointer of systems, but again constructing in place this type into the vector. So that's fine. Now a little trick that we might need to do is the system type that you're going to construct in place might require some constructor kind of arguments, and we don't know what they are, right? Like the arguments that somebody needs to construct their system are completely up to them, and therefore we need to kind of allow that to happen. So we're going to use some variadic kind of templates here, and that is so that anybody can pass in any system with any amount of, is it that way? I always forget. Let's format, yes. So effectively anyone can register their system. Anyone can register their system, and they can provide any arguments into the register system, which will then be forwarded into their constructor of their system. And I'll show an example of this later on. But there's some more things that we need here in regards to kind of what the system needs, and that is a like a signature. Like for example, what component IDs is your system interested in? Because systems effectively want to iterate over all of the entities with a specific set of components. So it might want just velocity or just transform or both. And we need a way for the system manager to know that. So what I've done and what I like to do is we're just going to use a bit set. But instead of just using a bit set, I'm going to actually wrap it in a class called system signature. And that's because it just makes it makes the usage of the bit set a lot, well, in my opinion, nicer. And you can be the judge of whether you think that's true or not. So we're just going to do this, and I think in ECS constants, yeah, we did. We wrote a maximum component count, so we only need a bit set of size maximum component count, and let's include bit set, yeah, and ECS. Okay, perfect. And so what do we want to do? What do we want to do to our bit set? We need to basically add a component to our system signature, and we need to remove a component from our system signature. So let's write that now. Well, set component effectively. So our signature, we're going to set components on it, and we're going to remove components from it. And whenever we set a component, we are going to, let's make this a bit nicer here. Whenever we remove a component, we're going to remove a component from the set. Component ID, and then we're just going to do the implementation for this as bit set component ID dot get, like that. And then we're going to do the same for reset component, and then we're just going to reset like this. So now we can create a system signature and add all of the components that the system signature is interested in, and then our system manager internally will just understand what this system signature looks like, and we're good to go. Now, what we want to do is we want to be able to register a system with a specific system signature. So let's do it like this. Signature. And I think we're going to store the signature in the system class here. So whenever you inherit whenever you create a system, you have to inherit, and therefore you need to you're always going to inherit this kind of member variable. And we'll leave it like that for now. So because here when we emplace back, you also get a reference back to the thing that you've emplaced, we're going to just now do this. Signature. Perfect. And then briefly, just so that we know, no, that's fine. Let's do that for now. So we can register a system, and our system gets kind of emplaced back into our system, into our list here, and then we can construct any type and forward on the constructor arguments, and we can tell the system manager what the signature for our system looks like. Perfect. Now we need to, let's do some simple things. So we need to tell the system manager whenever an entity is destroyed, right? Entity ID. So we want to iterate over const auto systems like this. And then, so effectively what we're going to do is we need to tell the system is going to track all of the entities that it's currently interested in, and we will make that list of interested entities later on, probably after this function. But for now, we're going to store those interested entities into an unordered set. And I think this could be another area of optimization, but we will look into that when we do the optimization video. And then all we're going to do is we're going to iterate over every system in the system. and we're going to call why is that not working? Entities dot arrays entity ID. Probably because it's private. Yeah. Okay, so we're effectively you're allowed to kind of erase something from an unordered set without it actually existing. So there's no harm in this. That's absolutely fine. And that means that every system, whenever a system iterates over its entities, you've now removed that entity, so it no longer is registered with that system. So that's fine. So now I spoke about earlier about kind of writing, like informing your system of an entity that it might be interested in. And so we're going to have this function called entity signature changed. And what this function will do is we'll take an entity ID and it will take a signature, entity signature, that that the entity is interested in. So the entity will also have a signature to say, for example, well, I have a velocity and a transform and a gravity component. And what we can do now with that information is we can iterate over all the systems and we can check if the system signature and the entity signature, bear with me, the system signature and the entity signature are a kind of set of each other effectively. And hopefully that will be made clear once we kind of start writing it, and I'll write a little example out. And so let's get on with that. So I think initially we are going to just iterate over all the systems like this. And then we're going to get out the system signature like that. And then we're going to do a bit of kind of bit set magic. Let's kind of write out the example first that I mentioned earlier. So example. So let's say the system signature is like this, and the entity signature the same length, perfect, is this. So this is the bit set. So the system signature might say, well, I'm interested in a component in this slot and the component in this slot. And the entity says, well, I've got components in all of these slots, right? And well, we can say, well, is this system interested in this entity? And the way that we can do that is by doing signature. Let's put this in brackets. Oh, sorry. System signature and entity signature equals 000 1100. So we just basically AND the two bit sets, and we say, okay, well, what do they? When we AND them, what's the result? And then effectively, this resultant signature, if that equals the system signature exactly, then then the system is interested in it. So effectively, if we write, let's write that out. So system signature and entity signature equals system signature, system entities dot insert entity ID. Else system entities dot arrays. Let's just make it so that if the system kind of instantly erases the entity to make sure that it doesn't exist in there. And the reason why is because there's a possibility that an entity might change. The entity might have kind of 1 time round, and then the system is interested. But then let's say it then changes to kind of 10000. Then the system signature and the entity signature will equal that, and therefore this will no longer qualify, and we need to remove the entity from this system. So we're just going to instantly erase it. Now you see here there's a error here, and the reason why is because system signature doesn't actually have a kind of operand or binary expression for the AND symbol. So we need to do some operator overloading, and we're going to do it like this. What are we putting here? System signature, right hand side. Let's just say if return right hand side. Wait, no, ignore me there. Right hand side dot bitset and bitset. And what this is saying here is there's no conversion from bitset to system signature. And the reason why is because we don't have a constructor that can take a bitset. So what we're going to do is we're going to make a private constructor that can take a std bitset, maximum component count, const this, and we're going to do bitset equals bitset. Done wrong here. I done what is wrong. Ah, silly. I need to explicitly construct it. So what are we saying here? We're saying, well, given the current system signature and the and you do the and operator on it, do the and operator on the 2-bit sets, and then construct the system signature. The reason why that was failing before was because I've made an explicit here, and it's saying there's no implicit. Whereas I think if I get rid of this, yeah, it will compile. So let's keep the explicit for the win. There we go. So now here, this should work. I suppose we should probably try and this needs to be const. Perfect. Okay, that's fixed. Now this one is failing because we don't have a equals overload. So let's do the same thing. And that does need to be a const return dot bitset equals bitset. There we go. So I think this should work for now, but let's just move on, and then we can kind of work out whether it does later on. So we need to just add a like a quick kind of, I think I called this system type up there. Type. We need a way of getting the system out of the registered system, because don't forget that the system manager owns the system. Like, it instantiates it and it owns the system in this vector. So we're going to do the same things we did earlier, and let's just kind of, well, in the component manager, and let's just do the same thing. So we're going to index into the vector based off of the unique ID. Remember, we give the ID based off of the size of the vector. And therefore every system ID should have a unique ID. And we can index into that array here. Now this is going to return a unique pointer of system. So what we need to do is we need to get that, and then we're going to cast it, because we return the system type, into a system type pointer like that, and then we're going to dereference it so that we can return a reference here. So I hope that makes sense. We can also return this. I don't know, we might not want to return a const because you probably want to do stuff on your system, but that's something we can change later on if we need to. Is that everything for now? Yes, I think so. Should we try and build this into our app? Let's add this. Include ECS systems manager. What I called it? System manager. Yeah, system manager. Okay, so system manager. So let's create a system here. And I'm going to create it up here. I'm going to call it animal system. I follow this theme, I suppose. Public system like this. And doesn't need to do anything at the moment. Manager dot register system. Animal system. Like this. I suppose what we could do is we could add a nice constructor int test for animal count, maybe. Just to prove that the constructor is working. So we've just added a trivial constructor here for animal count. And then we need to create a system signature for our animal system. So let's create a system signature. Animal system signature. Animal system signature, set component, and obviously we are interested in the animal size component ID. So here we are create system manager. Create animal system signature. System signature for the animal system. Register the animal system. So here we're saying the animal system is interested in the animal size component ID. And then what we're going to do is we're going to give that to this. And then we're going to, yeah, right. And then we're going to give it a constructor. Oh, my caps lock is on. We're going to give it a constructor of 10. Just to show that that kind of variadic template argument passed as args is given to this animal system constructor. Okay, so now that we've got this, we can go ahead and start registering some entities with our system. And the way that we do that is by using this entity signature changed function. Now, that function might seem really kind of weirdly named and not very user friendly, but if you remember in the previous videos, I've said that we're going to create this kind of ECS controller and entity wrapper class. It will all become a lot easier when we make that. which will be in the next video. So let's start registering some entities. At the moment, we've just got one entity, I think. Yes, this entity 4. So let's create a system signature for entity 4. And I'm going to steal this. Animal entity 4 system signature. Entity 4 system signature. And then we're going to inform system manager of entity 4. Entity signature changed. Entity 4, dereference it, remember, because it's the result type. And then entity 4 system signature. So hopefully we've now told the animal system about this entity 4 system signature. And so what I'm going to do is I'm just going to add a do or like an update function. And what we're going to do is we're going to auto entity entities printf as always the entity ID. Entity.get like this. That's going to complain. Fix that format specifier. Okay, so remember we need to get the auto reference animal system. We need to get the system out of the system manager. We forgot to get this animal system ID because the system manager owns the systems. And now that we've got this animal system, let's call, does it return here? This should be a update. And why is that not happy? Yeah, so this is the issue I said about kind of const earlier, but that's fine for now. We'll just leave it like this. So let's build and see if it works. Signature is not a member of Billy Billy. Okay, that builds. And fingers crossed, it should work. I'm not going to test it just yet. I've got bad luck, no space. No new line. Let's rebuild and we'll check again. Of course. Let's just undid all this. Const. Right. Entity ID 0. And that's perfect, I think. But this is quite boring, right? Because there's not much you can do with an entity ID. By the way, the only entity ID we've got is entity ID 0. And so entity ID 0 has been registered with this system, which is perfect. It's exactly what we want. But it would be pretty boring if the system could only get the entity ID. Really what the system wants is access to its components. So we are going to give every system a handle to a component manager like this. And I'm going to construct the system manager. Make this a reference. Component manager. Component manager. component manager down here. And then every time we make a system here, we will go component manager equals component manager. So now this system needs to be constructed with the component manager, and this here, oh dear, default constructor of system is implicitly deleted because field would be initialized. Okay, we'll make it a pointer. Component manager. Okay, there we go. So now we should have access to the component manager. Yes, we do. And what we can do is we can get the component of our entity here. But we should probably get the component ID out. So if you remember, this is why I wanted the Veredit templates, because now what we can do is we can do this. We can component ID, animal size, component ID, and we'll probably have to move this animal size struct out so that we know we can reference it here. So we're going to construct the animal system with the component IDs that it's interested in. We'll store a handle to it. ID animal size. Construct it animal size comp ID animal size comp ID. Animal size comp ID, like this. Right, and we should probably system manager. What's the problem here? We need to get the address because we're now doing a pointer. Animal system needs to be constructed as a Veredit template now, remember, with the animal size component ID. So what did we do there? We changed the constructor to take all of the component IDs that this system is interested in, so that when we iterate over the entities, we can actually pull the component out of the ECS and get the information we want. So you can see here that we passed that component ID into the animal system, and we should now, if we just copy this, the ID, entity, also animal size. You copy the same pattern. LLU. Feet. Feet. Head. Face. Feet. Head. Face. Gets. Okay, I hope this works. Hey, perfect. So you can see here that we've been able to create a system, inform the system manager what components our system's interested in. We've then gone and told the system manager that there's this entity that has these components on it. And then when we've gone and got the system and called the update function on it, which does some random stuff, but for us, it just iterates over the entities that it's interested in. And then we call get component on it. We then print out the information. And as you can see, that information about feet, head, and face is the same component information that we pulled out of earlier when we called get component, which is great. Now, just to prove that we can destroy, let's do this. So we'll just do like if entities dot empty. Yes. It's a no discard, but I think that's fine for now. If entities dot empty, then printf no entities for this system, and then we'll return it. That should work. No, it's not happy. What am I doing wrong there? It's late. I'm tired. Right. So yeah, same happening here. And then what we're going to do is we're going to inform the system manager. Well, actually, we're going to entity destroy entity manager dot destroy entity for. So we've destroyed that entity. And then what we need to do is we need to inform the system manager about, we can probably also do the component manager, entity destroyed, entity for, and then we do the system manager to entity for. And then we're going to do the same thing and we're going to run the same update, and then hopefully no entities for this system. Perfect. So I think we've achieved everything that we wanted to achieve in this video. And I hope you think it's as cool as I do. I think it's really cool. You can have kind of these systems are interacting with different entities and components and different sets of components on entities. And yeah, you can destroy and create them, and the system will just in the background update as necessary, and your system just has to worry about itself, and the ECS will handle what information and what entities it needs. There we go, the system manager for the ECS that we're writing. Bit of a longer one today, but I think that's okay. We managed to go through quite a few bits and covered a lot of different stuff, and most importantly, we implemented it successfully and it worked. So I'm happy with that. As you can see though, the design is a little bit complicated. You kind of have to create entities and then add components and then add a system and then register the components of systems interested in, which is all fine. But then every time you create an entity, you have to go back to the system manager and tell the system manager that the entity has been created and what is its signature. And then you have to kind of update the system manager every time you remove a component or add a component, and it would just get quite annoying as a developer to do that. So in the next episode, we're going to do ECS controller and the entity wrapper, which will focus on removing a lot of that boilerplate and making it a lot nicer to use. So I'm excited for that, and I hope you stick around. I really hope you enjoyed this video. I appreciate any feedback or anything that you've got, and I really appreciate the fact that you're watching, so thanks again. I'm still quite new to this, so any feedback that you have, any comments, then leave them down below. So let's leave it there. Thanks again, and cheers. I'll see you in the next one.